Hello everyone, hope you are doing well. Welcome to the online platform Civil Techno Bricks. Guys, here we will tune for the instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today we will go through the core concepts related to the GPS tracking and its applications of GNSS. So GNSS technology which provides accurate positioning, navigation and tracking services which supports surveying and infrastructural management activities. GPS tracking continuously records the location of moving or stationary objects which improves monitoring and decision making in engineering projects. So the technical overview of civil engineers which uses GNSS for assess tracking and project management to enhance the efficiency in transportation and construction sector. The mechanism for that GNSS which based on the architecture of the three segments, that is space, control and user. The space segment consists of satellites orbiting approximately 20,200 km above the earth surface. These satellites continuously transmit navigation signals. They are of 24 plus satellites. The control segment monitors satellite health and updates orbital information with reference to the ground stations, which maintain the time accuracy and system reliability. The user segment that receives satellite signals, which computes positions that determine through the ranging and trilateral principles. The vehicle tracking system concept. So vehicle tracking system receive satellite signal through GNSS receiver, where the position information is continuously updated and recorded, just like the Google Maps, as we are using while traveling from A location to B location. The tracking data which helps to monitor vehicle movement and operational efficiency, that supports fleet management or journey schedule and transportation planning, just like from RMC plant to the nearby construction project. So urban cans or urban utility and tunnels or roadways which cause signal blockage or any multipath errors, these are also factors can reduce positioning accuracy by using that vehicle tracking concept. Most important, that is data transmission methods. Here the real time data and the post processing data. Now the real time data which is based on the navigation or real time kinematics. On the other hand, the post processing data which is required high precision to update that data as a input or process that data for the application point of view. So here real time systems transmit correction data through radio or GSM networks. They are widely used for navigation and real time kinematics applications. The post processing which stores field observations for later analysis, where the corrections are applied after data collection to improve the accuracy of the data. These real-time methods support immediate positioning requirements and post-processing, which provide higher accuracy for engineering survey and applications. Now, fleet management, or we can say that the logistic point of view, the transportation of logistics from A location to B location, they are also most important for tracking. So GNSS improves route planning and vehicle utilization efficiently, which reduces the travel time and operational cost in the routing methods. Fleet monitoring helps to manage the fuel consumption and maintenance schedules also, so that the real-time information which improves transportation efficiency. The logistics optimization enhances project productivity, where civil engineering projects benefit from improved resource management. Now, that logistic optimization which is most important nowadays for the transportation point of view, where huge amount of goods are travel from A location to B location with reference to some thousands kilometer. For that, route planning, fuel monitoring and ideal time reduction are most important phenomena. The GNSS in land surveying, most important point for the survey point of view. Nowadays, the updated technologies, that is code-based DGPS, which provide approximately 1 meter position accuracy, which is commonly used in GIS and mapping applications nowadays. The carrier phase DGPS achieves centimeter level accuracy with the precision and which is most suitable for engineering layout surveys. The base stations transmit corrections to rover receivers, where differential correction significantly improves position and its quality. Next will be the GNSS in topographic mapping. Here the topographic mapping considered with reference to the curvature of the earth, that is geodetic earth, with reference to some TIN model or digital elevation model or surface model. The direct georeferencing combines GNSS and IMU technologies, that is direct georeferencing, which is a combination of GPS plus IMU. This enables accurate positioning during the data collection, where the surveyed points are used to generate triangulated irregular network, that is TIN model or terrain models. These models represent the Earth's surface digitally. So actual Earth surface is converted or considered as a digital model. This digital terrain model supports engineering design and planning. They are widely used for the highway, dam and urban projects construction. So the point capture to the TIN generation, and at the end we can correct the digital terrain model for the topographic mapping. So that is the actual application or usage of technology, that is GNSS. Next one will be the cadastral surveys. We are establishing legal land ownership boundaries for the town planning and architectural point of view. That will be the most important survey, that is cadastral survey, which establish legal property boundaries with accurate boundary determination is essential for land administration. So centimeter level positioning accuracy is generally required, that high precision GNSS receives the data commonly for the further analysis purpose. Survey measurements are verified before updating the land records, and that resulting information supports cadastral information systems. The workflow is of the three steps: field measurement, then verification, and followed by the output, that is cadastral information system with the centimeter level precision. Next one will be the highway alignment survey. GNSS used in the highway alignment point of view to mark the right of way with reference to the center line or alignment. The GNSS supports route selection and alignment of planning for highway, railways, tunneling with accurate positioning to identify the optimal transportation corridors. The satellite data can be integrated with GIS and land use maps to improve the planning in densely populated urban regions. The alignment surveys, which help to reduce construction and environmental impacts, to provide the better route planning, which helpful to more efficient infrastructural development. The case study point of view, we can take the Hyderabad highway alignment surveys that are used for satellite data to plan road widening in dense urban areas, overlaying major networks onto land use maps. The construction point of view, the construction layout and the machine control. Here in construction industry, for huge construction projects, we use advanced construction equipments. So these all also equipments or machines must use it, that GNSS or any type of models for the designing or construction activity purpose. Digital terrain models can be uploaded directly into machine control systems with reference to GNSS, which provides continuous positioning of construction equipment. Automated control improves grading and excavation accuracy, where machine guidance reduces human errors and duration of construction also. So the construction productivity and quality are significantly improved on the basis of GNSS based automation support for modern infrastructure projects. That is, digital terrain models are uploaded directly to the machine's computer to automatically control blade elevation, eliminating manual stacking with reference to the GNSS antenna as a rover or receiver. GNSS in navigational purpose on the global level, where GPS of USA, GLONASS of Russia, Galileo of Europe, Beidou of China. These are all the interoperability, which is based on the augmentation systems like satellite based augmentation system. For example, VAS, IGNOS, Gagan use geostationary satellites for error correction. So major GNSS constellations include GPS, GLONASS, Galileo, where multi-constellation tracking improves satellite availability. Interoperability increases the positioning, reliability and accuracy, where more visible satellites improve geometric strength. So the augmentation systems provide corrections. These systems further enhance that navigational performances. For the marine navigation and hydrography point of view, above the water surface and below to the water surface, 2 points are there. Below to the water surface, there will be a mathematic sonar, and above water surface, there will be the positioning through the satellite where radar altimetry is used. So GNSS provide accurate vessel positioning or accurate ship positioning during marine surveys, which is reliable for coordinates, are essential for hydrographic mapping, where the radar elementary and positioning systems support water depth measurement. These techniques more helpful for coastal and offshore engineering projects, just like dam, docks and harbor construction, or any type of sealing type of construction projects. Applications for that marine navigation in the hydrography domain, which include dredging, port development and bridge foundations with reference to the accurate positioning for the marine construction activity. That is disaster management point of view, we can use that GNSS. GNSS is used to monitor tectonic movements and ground deformation which occurred due to some earthquakes or any disaster, which helps to assess that geological hazard before disasters occur. So the positioning data supports rapid emergency response operations, assessment, and the location information so that we can improve the relief planning. The satellite based monitoring during pre-disaster or the post-disaster, just like the tsunami in Sumatra, as explained in the pictures, rapid response assessment of pre-disaster to that post-tsunami, where engineers can assess damage and plan recovery measures effectively. That disaster monitoring constellation collaboration will operated and the huge amount of disaster may be analyzed in short duration so that the preventive measures or mitigation techniques will apply effectively. Nowadays, most important point for the urban development point of view or city development point of view, that are the smart city and infrastructure planning, where the 4 M's are most important nowadays: measurement, mapping, monitoring and modeling. With reference to the GNSS that supports urban GIS through measurement, mapping, monitoring, modeling, these functions form the foundation of smart city development, where the spatial layers such as utility layer and zoning of maps can be integrated with the reference of GIS, which enables for urban infrastructure management. That is layer 1 physical city, layer 2 utilities, layer 3 zoning map. Likewise, we can divide each and every city in n number of layers. That layers are most important and accurate with reference to the geospatial data, and that data which improves planning decisions for the engineers. They use the GNSS for sustainability approach in the city development or in urban planning. Just the case study point of view, we can see that Hyderabad city, Hyderabad urban development, the GNSS accuracy ranges from meter level navigation to millimeter level engineering surveys, which required for project objectives. The integration of GNSS, GIS, and satellite imagery improves that the planning efficiency, digital workflows, which reduce the field effort and increase productivity. At the same time, that Hyderabad's transportation planning benefited from geospatial technologies so that the satellite data and ground control points supported urban infrastructure development with reference to the accuracy, efficiency, and integration point of view. Stay tuned, guys. Happy learning.